Hello, I'm JP Walsh, the director of the Coastal Resources Center and a professor in the Graduate School of Oceanography at the University of Rhode Island. On behalf of the organizing committee, I want to offer a warm welcome to everyone attending our fourth session of the Global Ocean series, focused on the Northeast US continental shelf large marine ecosystem. Thank you all for joining, and I know many others will be coming in as the event begins. I also want to thank our speakers, my co-organizers, and supporting entities. Please see the Global Ocean Series website for speaker bios, partner information, and other information. Many of you know our in-person event scheduled for this spring at URI was canceled. We felt that it was important to advance the conversation in planning for the decade of ocean science for sustainable development, specifically to talk about linkages between efforts being done on local science and management with those being done at larger scales like large marine ecosystems. In short, there have been many successes at many scales, and we need to build upon and bridge between local and large marine ecosystem actions. The goals for the summit are fairly straightforward. First, to better understand UN goals, the ocean decade objectives, and connections to work being done by scientists, organizations, communities, and countries. To share science and management efforts, especially those that link across scales from LMEs to local actions. And then third, to discuss and identify how to improve efforts and linkages immediately and then over the decade. I want to give a quick recap of the earlier sessions. There were some really great discussion. The first session provided a wonderful backdrop for local and global perspectives. We heard from Vladimir Rabinin, the executive secretary of the IOC, and he reminded us that humankind is running out of time to manage the oceans sustainably. Also, Dr. Sandra Whitehouse from the Ocean Conservancy highlighted that ocean planning requires robust stakeholder engagement and science. The second session hosted a focused conversation on Asia and the Pacific. Again, we had several great panelists, a couple that I'll quote from. Dr. Nigel Armada, the chief of party for the USAID Fish Right Program in the Philippines, he noted that there's a sweet spot between governance and ecosystem scale that we need to contend with. And Dr. Cerf and Dede Nagi from the Gulf of Guinea Regional Fisheries Commission emphasized that capacity building is especially important, as without capacity, decisions and actions cannot be taken. And this is a challenge for countries around the world. The third session focused on Americas, Africa, and Europe, was a regional panel and discussion. There were many excellent points on the progress that we're making. Laverne Walker from the Caribbean Large Marine Ecosystem and Vivian Kinyanga from the Benguela Current Large Marine Ecosystem and many others highlighted some of the many successes. Finally, I want to highlight Vladimir Rabinin again. He explained for the decade that science has been used to sound the alarm, but now we need to provide solutions. And I think that's what we'll certainly be talking about today. Before getting into the program, I want to review a few logistical points. First, this event is being recorded. So smile, you're on camera for the panelists. For those not familiar with Webex, your view of the speakers and slides can be adjusted using a button in the top right of the Webex window, and you can toggle between different views. For comments to hosts or panelists, attendees, please use the chat, and we will be monitoring that and sharing the chat with everyone. Please take a moment now and introduce yourself on the chat by giving your name, affiliation, location to the panelists and the hosts. And again, we will share that with the whole audience. At the end of the program, we plan to have time, or really throughout the program, time for questions from the audience. For questions, we encourage you to please use the Q&A tool. which is on the right side of the screen. When entering your question, if you want to ask it verbally, please let us know and we can find you in the list of many attendees. So to chair the session today, I want to introduce Jen Mccann. Jen, I'm going to hand it over to you in 1 second, but finally, I want to thanks again to all the panelists. Jen, please take it away.
Great, thank you, JP. Can you hear me all right?
Loud and clear.
All right, great. Well, thank you everyone for spending your Friday morning with us. We really appreciate it. I am Jen Mccann. I'm the director for the U.S. Coastal Programs at the Coastal Resources Center with JP, and also the director of extension for Rhode Island Sea Grant. As many of you know, the University of Rhode Island has played a significant role in proactively planning our coasts and oceans in Rhode Island and overseas. And the scales have ranged from small harbors to multi-country or multi-state initiatives. So we understand that there's different scales and there's different issues that each of these places are facing. And our approach is really to consider the whole ecosystem. We want to ensure that we're encouraging the appropriate development that considers sustainable use and wise management within these different scales and areas. And to ensure that we're using the best available science and also a transparent process to ensure that all sectors, all resource users and entities have a seat at the table. And a good example of that approach within the Northeast Large Marine Ecosystem is the Ocean Special Area Management Plan, the Ocean SAMP, which was the tool which helped to determine where the Block Island Wind Farm would be sited within that region. It's a good scale, it's a small scale within this Northeast Large Marine Ecosystem. And again, we're going to be hearing about larger scales here today on the panel. One of our other responsibilities here at URI is to ensure that we are creating opportunities and forums for places for people to learn as we go so that we can do better. I'm sure many of you have attended events where it's like, oh my gosh, we've already had this conversation. Oh, or we made that mistake already. Or, you know, I have a cool skill or technique that we used here that we could apply there. And so we see this forum as a real opportunity to continue that conversation and to learn as we go and moving forward with this. So the forum for this event is to, each one of our panelists is going to give a 5-minute summary of who they are and what is of importance to them. The order will be, because I'm not sure if we went over this, is Nick, Tatiana, Andy, Jeff, and then Lindy. And again, as JP mentioned, we want to hear from you all. So please put your questions in the Q&A, and we will be taking a look at that and trying to integrate them into the conversation. At the end, we will have a final wrap up. And again, as JP said, this will be recorded, so you can listen to our beautiful voices again or share them with others. So with that, Nick, I'm going to pass it off to you.
Okay, thank you. Can you hear me okay?
Yes.
Great. And I was told yesterday that I was going first, so this is not news to me. So thank you, Jen and JP, and to my fellow panelists. It's good to see you all. It's been a long time since I've seen some of you, and I hope we can see each other again sometime soon in person. Until then, this will hopefully do. I'm Nick Napoli. I have primarily two roles. I'm the Ocean Planning Director for the Northeast Regional Ocean Council, and I'm also an advisor to the Mid-Atlantic Regional Council on the Ocean. Next slide, please, JP. And what NROC and Marco are regional ocean partnerships, and they cover these two regional ocean partnerships in orange and blue here on the slide, cover the majority of the large marine ecosystem we're talking about. And Regional ocean partnerships also exist in other parts of this country. They also cover a large portion of other large marine ecosystems you can see here on the slide. And they've all been in existence for at least 10 years. And in the case of the Northeast in the Gulf of Mexico, over 15 years. And they are voluntary organizations that are convened by state governors. And depending on the region, they're in collaborations with different governments and partners. But generally, their intent is to be inclusive, include state, federal, tribal members as much as possible, include partnerships with academia, industry, NGOs, and other regional organizations. And importantly, they're not focused on any single issue. They're really looking at priority regional issues. So the issues that are priorities for one region are different than the other in some cases. Next slide, please. So in the case of Marco and NROC, who I primarily support at this point, they each have had work plans since their inception around their priority regional issues. And in 2016, each region also developed a regional ocean plan. And those plans generally provide some guidance and best practices and regional actions to advance management, and these are all sort of within existing regulatory authorities. There's no new regulatory authority, but it is looking across resources and sectors and providing guidance and best practices and regional actions to advance, make progress in some of those regional priority areas. Importantly, they also have developed alongside what are called regional ocean data portals. On the bottom left, you're seeing the Northeast Ocean Data Portal. I forgot to include the URL, but that's northeastoceandata.org. And on the bottom right there, you're looking at the Mid-Atlantic Ocean Data Portal, and that's portal.midatlanticocean.org. And really what those are they're information sources about, or in the early 2000s, and as Jen mentioned, there was in the mid 2000s, there was some efforts to advance state planning efforts in Rhode Island, in Massachusetts, and that was in response to in the early 2000s where there were liquefied natural gas proposals, offshore terminals for liquefied natural gas. There was Cape Wind project. There were aquaculture proposals. A number of things coming in offshore that maybe hadn't been considered before. And in response to that, some of the states started developing plans to manage that. And at the same time, while these regional ocean partnerships were being established and getting underway, there was acknowledgement that a regional information base and maybe some consistency and looking at data and information from a regional perspective would help some of these state planning efforts, especially in the Northeast, in the Mid-Atlantic, where the states are closer together perhaps than others. So what both of these portals contain are map products that look at the footprint and the change over time for resources and activities. Importantly, what we spend a lot of time, and probably, one of our niches is that we spend a lot of time vetting these data and identifying potential map products from existing data sources with the people who know that activity or the resource best. And it goes across, if you go to either site, you'll see we span many different topics and themes in terms of resources and activities. Next slide, please. I threw this in there. I know there's going to be a lot of discussion about offshore wind and fish, so I left off maps related to offshore wind and fish, but I wanted to provide an example of why a regional data set is necessary. This is actually looking at vessel transit. From on the left, you're seeing all vessel transit in 2019 that's derived from an AIS, which is a AIS receiver, which a lot of vessels carry and over a certain size are required to carry in order to indicate their position to other vessels. But it gives us a good sense of where vessels have been over time. And you can see the broad picture on the left, and you can see some regional connections that are really important for some, perhaps when there's a local plan being developed, some of these regional connections might get missed. And you can see some really important regional connections. And you can also see how activity changes throughout the year. Actually, on my first slide was an example. If we could flip real quick back to that, JP, that'd be great. This is actually red-throated loon. And on the left, you're looking at the red-throated loon in wintertime, and then on the right, you're looking at the red-throated loon in spring. And so you can see in how activity changes over time, and how if you don't look at that regional picture, you might miss a big part of the story. I think I'll move to my last slide now, JP. Thank you very much. So who uses the portal and how? I'm not going to go through all of this, and this isn't even, these are just some examples from the Northeast of how the Northeast Ocean Data Portal is being used, but a lot of them are similar in the Mid-Atlantic as well. I'll point to a couple, and now in New England, we have 3 states that have developed ocean plans: Massachusetts, Rhode Island, and Connecticut. And those states have both used the portal to inform their planning efforts, and they've downscaled some of the data. And in some cases, some of our data are great at regional scales, and they're high enough resolution to use at a local scale. And in other cases, you know, it depends on the question as to how you would use the data. Other examples that we have are certainly the federal agencies. EPA has used it to place alternatives for a disposal site or a proposed disposal site up online, so that during the public comment period, everyone could obtain the location of that proposed site and evaluate it with others. The Coast Guard uses the Mid-Atlantic portal to put up proposed anchorages during the public comment period, so that folks can go and look at a proposed anchorage site and use the vessel data to evaluate it and provide comment. And the last thing I'd say is on the bottom left here, you see an example of our the graph, and in 2018, we had one day where our data services were hit by far the most, and that was the day before the competitive leaf sale off of southern New England. And that may be a coincidence, but I'm not sure it is. So with that, I will pass it on to Jen for either a question or the next panelist.
Thank you, Nick. And again, there's nothing like sitting around a map and looking, you know, bringing people together, you know, from diverse backgrounds and looking at these maps, and it's sort of a calming effect, I would imagine, too, to, you know, some people love to show where they've been fishing or what is of value to them. So that's wonderful. Do you, I know you have some examples of how individuals, as you're saying, have used, or organizations have used these maps. Have you been able to, are there examples where you've been able to use these maps for promoting multi-use strategies? So 2 entities sort of co-using the same resource intentionally.
That's a great question, Jen. I think, you know, I could go back to the last slide again, JP, if you don't mind. And you know, again, I could talk about any of these examples. And, you know, I guess I would say that first off, multi-use is difficult. Our laws, our authorities, financial incentives are really geared towards focusing on a single activity at a time. But I would say that a couple of things have evolved over the last 10 years. First is that at least those sort of single sector efforts or single use efforts are now better informed of the entire picture than they were 10 years ago. So now when you're going into that, you know, whether it's planning for a single activity, you have a better consideration of everything else that's going on out there. I'd also suggest that some of these smaller scale efforts in Massachusetts, Connecticut, they are really looking at multi-use approaches in their planning efforts, and those are the Massachusetts Ocean Plan's on its 3rd revision now. Connecticut is waiting approval of its first plan. Both of those efforts have relied heavily on our data for providing that regional context, and also for some of these uses, using the data directly where it's high enough resolution in a smaller area.
Thank you, Nick. And on another note, I know we encourage your panelists to talk about successes, but also failures or challenges, I guess, as we move forward. So feel free to bring those up as well. So Tatiana, we're gonna go to you next.
Okay, everyone. Good morning. So I'm Tatiana Reinierson. I'm a professor of oceanography here at the University of Rhode Island. Today I'm going to talk to you about the Northeast Shelf LTR because I'm an active member of that. I'm going to talk about, so I'll tell you what an LTR is in a moment, but I'm going to talk about the Northeast Shelf from the perspective of the shelf itself, but also part of my role here at the University of Rhode Island is to run the Narragansett Bay long-term plankton time series. That's the longest running time series of its kind in the world. And we do weekly sampling of Narragansett Bay. That kind of intensive long-term sampling is really revealed and is revealing a lot about how Narragansett functions. One of the goals for this LTR is to start understanding the shelf, I would say, as well as Narragansett Bay, even though I feel like Narragansett Bay is a tough one for us to understand. But getting more information out on that shelf is helping us understand the shelf better, but also helping us understand the connections between really near shore habitats and then those shelf habitats. And I want to point that out because I think on this call, we're going to be talking a lot about resource use. And often we talk about things like a bay separate from the outlying waters. And really there's a connection, an intimate connection between the two. So for the rest of this presentation, I'm going to talk about this Northeast Shelf LTER, which is a long-term ecological research project, which is sponsored by the National Science Foundation. I'm speaking today on behalf of a whole team of scientists from Woods Hole Oceanographic Institution, University of Massachusetts, Wellesley College, as well as Noaa and the Northeast Fisheries Science Center. And I want to give a special shout out to Heidi Sosik, who is our lead principal investigator. She is at the Woods Hole Oceanographic Institution and does a great job herding cats in this large project. Before I move on to the next slide, I want to call out these two pictures I'm showing you. These are two images from two of the cruises that we do. We do them 4 times a year. The one on the left is a winter cruise where you can see very large waves probably about to inundate a lot of the scientists right there on the ship, as well as summer cruises where you have absolutely flat, calm water. So we get to be out there in all sorts of conditions to see what's going on. All right, next slide, please. So we'll talk about this more, but the Northeast Shelf is a really productive temperate ecosystem, and it's subject to basin scale ocean processes. So for example, things that happen out in the ocean are really influencing what's happening up on the shelf. This ecosystem is also exposed to rapid climate change. We have a lot of human impacts, and whatever happens on that shelf has wide-ranging ecological and societal consequences. Next. So the goals for this LTR project are to understand and predict how planktonic food webs change in response to changes in the physical environment, and then how those changes impact ecosystem productivity. One of the things I didn't mention on the first slide is that this is a brand new LTR. So we've just started about 2 years ago, and we've had our first set of cruises. And so hopefully, if we do a good job, the LTR will be funded for the foreseeable future. And that will give us a really large data set to start working with. And that really speaks to the kind of data that Nick is really keen to have to help us make these kinds of decisions on the shelf. Next slide, please. So this video is from Gangchen Chen, who's a co-PI on the LTR. And here he's showing a video that shows just how dynamic the ecosystem is. Blue colors are cold water, warm colors are warmer water. And you can see how much temperature changes over time with season, but we're also seeing a warming of the shelf over time. So this video goes from the 70s all the way up to 2016. On the right-hand side, you'll see an image that shows the grid of our sampling for the Northeast Shelf LTR, which ranges all the way from the Gulf of Maine in the north down to Cape Hatteras in the south. And those large sampling projects are in coordination with Noaa and their ecosystem monitoring program. And then you see a yellow swath. That is a focal transect where we are doing 4 cruises a year to get information right across the shelf about what's going on. Next slide, please. And I want to point out one of the reasons that we're doing this is that the shelf is known to have really efficient food web connections from the microscopic primary producers you see on the left, right through the herbivorous consumers. These zooplankton eat almost all of the primary production that's generated out on the shelf, 70 to 100% of it. And then that gets transferred up to the alewife and the other important fish and fisheries that are existing out on the shelf. Next slide, please. Next, please. So what we're trying to do is understand these seasonal to decadal shifts across the Northeast Shelf. And so here, what I'm pointing out is on the top graphic, you can see that in the winter, we have a lot of mixing, we have winter cooling and convection. And then as you move to the right, that summer shelf, what happens is the water column stratifies, you have a warm layer on the surface, a cold pool at depth, and then all the way on the right, there's a complex set of physical processes that lead to nutrient exchange and temperature exchange from the offshore waters up onto the shelf. And where we are in that seasonal cycle really influences whether we have a situation with a high export of phytoplankton biomass up to fish or a low export of phytoplankton biomass and energy up to fish. And we're really trying to understand what those conditions are that lead to different exports. And the last slide, next, please. And so I just want to finish by saying what we're trying to do, common ecological mechanisms and cross-scale feedbacks that allow us to understand seasonal and interannual variability, decadal scale and regime shifts, as well as the influence of climate change. Thank you, and that's all I have for now.
Thank you, Tatiana. My understanding, as you said it, you're sort of beginning this process. Have you, how are you connecting with the management community or the regulatory community to share some of this amazing information?
Yeah, that's a great question, Jen. Because it's so new, you know, a lot of our data is really literally just being processed now. And because we have a strong connection with Noaa, we're able to leverage that connection to work with management. And so as we get more data and we have more information to share, we have a portal, shall we say, to the stakeholders there and to policymakers.
Perfect. That's wonderful. That's really exciting. Okay, and thank you, Tatiana. Andy?
I think I'm off mute.
I can hear you perfectly. Great.
Great. Good morning, everyone.
Morning.
So I'm having a connectivity issue, so I'm gonna assume I can see the slides, but I may not see the slides. But you'll be able to hear me because I'm dialed in.
Okay.
So thank you very much for inviting Noaa Fisheries to join this webinar and participate in this Global Ocean Summit event. This is really fantastic. I'm going to talk about large marine. I think it's useful when we talk about the concept of large marine ecosystems, and you know, these panels are going to talk about, you know, different scale of how we work across from small to large, to talk about management and science in the context of something tangible. So my presentation is going to talk about the sort of the LME scale for fisheries and offshore wind coexistence. I work currently at the Northeast Fisheries Science Center as the fisheries and offshore wind lead in the region. Next slide, please. Also would be, as we're progressing, just my co-author, co-presenter who's unable to be here is our Science Center Director, John here. So I have an awesome job. I love the work that I get to do. And working at the Northeast Fisheries Science Center is part of a fantastic scientific enterprise that Tatiana had alluded to. We have labs from Maine to Sandy Hook. Can you click the slide? And one reason I love what I do is this is the first position that I'm working at the scale of the way the ecosystem is organized in. So our span of operations, like I showed you before, includes the entire scale and scope of the Northeast Shelf large marine ecosystem. This cartoon is basically, if you had your elevator speech for the Northeast Shelf ecosystem, it might be this. You know, this is what drives everything that happens in terms of the biology and including the human dimensions. So the Northeast LME is shaped by a number of factors that includes the flow of water from the north into our region, influence of major river systems, winds, and tidal forces. And the physical oceanography of this region is influenced by two major current systems: the equatorial flow of the Labrador Current from the north and the poleward flow from the Gulf Stream from the south. Water mass characteristics such as temperature and salinity and oceanographic features like circulation patterns and the position of frontal zones affect every aspect of the ecology of the system, and including the distribution and patterns of species at all levels of the food web, the basic biology of individual species, and the dispersal and migration pathways as well. And it helps also explain the types of human uses that are happening in this ecosystem as well. So we are, as Noaa Fisheries, we are, a delivering marine resource agency, and our scope covers marine mammals, sea turtles, and other important protected species, to advancing ocean aquaculture, and to putting food on the plate and advancing sustainable fisheries. Next click, please. I'm going to stay on this slide. Yeah, so this is an example just from a few years of sampling from our science operations, and the assessments basically span the entire range of our LME boundaries. And actually, our scientific efforts go beyond our boundaries because they require international collaboration with partners who are co-managers in some of our fisheries, like Canada, for instance. Next slide, please. So offshore wind development, I think Jeff is going to give you all sort of an overview of the industry and where it's at. I'm going to give you one snippet just to put it into context. We are about to build out the offshore wind industry in the U.S., building on the successes of our pilot project that was developed in Rhode Island State Waters, the Block Island Wind Farm. We're going to go from 5 turbines to what we expect or anticipate from now to the year 2030, a couple thousand turbines and potentially 8,000 kilometers of submarine cable. And so this new ocean use that's being advanced, notably by many of the states who are looking to address climate change and produce alternative forms of energy in the form of renewable energy, is something happening across our entire large marine ecosystem. And this interfaces with many parts of our Noaa Fisheries mission. So in like 1 minute, I'm going to go over just quickly some of the things that we care about with offshore wind. As we are trying to advance offshore energy development, we also have to consider it within the context of this large marine ecosystem and the things that we care about, like the species that are protected under the Endangered Species Act, like North Atlantic right whales, or the 48 managed fisheries in our region that are operating or have been operating for decades, if not centuries in this region, to the complex habitats and the ecosystem itself. And effects from offshore wind are going to occur during the pre-construction phases, the construction phases, the operation phases, and the decommissioning phases. And basically those 4 phases of development for each wind farm is roughly from -0 years up to 30-year lifespan. So this is a issue that is coming before our large marine ecosystem. And I don't know about many of you on that are listening in, but for me, this is something that I'll be working on for the rest of my career. The types of effects that we care about related to these phases of development are the acoustic surveys and construction and operational noise, vessel traffic, creating fixed foundations in the seafloor, sediment suspension and deposition during the construction period, the submarine cabling and electromagnetic fields that could potentially influence species and wildlife, the lighting and navigation, and then we're going to be creating 2,000 little islands of habitat across the shelf. And so the habitat conversion of taking areas of relatively flat bottom and creating islands from the bottom to the surface. And so these different effects affect the Northeast Fisheries Science Center mission to advance sustainable fisheries, wildlife, and manage ecosystems and habitats. And some of the impacts and effects that we care about are exclusion of fishing activities or disrupting fishing communities, creating new habitat, different types of biological effects, the exclusion of some species and the attraction of others as we create new habitat, changes in behavior of these animals, changes in feeding, socializing, nursing, how they reproduce and where they reproduce, and then overall, cumulatively, how this changes the ecosystem, changes in flow fields due to changes in oceanography, prey, and habitat, and an area that we are very slowly, I think we're catching up now, coming to realize would be affected, which is really a fundamental, is what are the impacts to our current scientific enterprise in the region. So the next slide, please. So it looks like my video snapped, but if someone could just confirm you're looking, there we go, looking at some survey strata. So this has been an underappreciated problem or opportunity, the way you look at it, in considering the offshore wind development emerging uses. We have a combined total, can you go back? 317 years of combined survey effort across the LME ecosystem. These surveys are vital to managing the ecosystem, for managing fisheries, and for contributing to international science and climate assessments, to the conservation and recovery of protected species like the highly endangered North Atlantic right whale. So with wind farms coming in as a new use, most of our surveys are constructed in these areas according to a mathematical design or statistical design called a random stratified design. So if we put a wind farm in these areas in one of our strata, we can no longer randomly sample in that strata. Not to mention, when we place turbines a certain distance apart, some of our vessels and ships, similar to commercial fishing vessels, may not be able to access those areas. And also, we are going to be changing, as I said before, the habitat of these strata. So what's happening in wind farms is going to be different than what's happening outside of wind farms. And so the variant structure of important variables such as habitat, abundance, the distribution of species, and also the vital rates of species are really critical for us to understand and manage to meet our management objectives. Could you go to the next slide, please? So some of our key challenges is the pace and scale of development. And I don't know about all of you working in coastal management, but we're often forced to solve problems as they're happening before us versus solving a problem before the problem arises. I think that's just the nature of our game. And we have large scale development happening, and it's happening fast and over a large area. So some of our challenges are, let's do no harm to our current scientific enterprise, because it's actually critical to advancing offshore energy, because that data is really important for both the Bureau of Ocean Energy Management, our sister agency, who are advancing offshore renewable energy, and our Department of Energy. In order to advance offshore energy, we need this science. So addressing these impacts to our scientific surveys and assessments is paramount. Effectively engaging our commercial and recreational fishing industries in the processes for offshore wind development planning, regulatory, and also in collaborative monitoring is key. And another key challenge is establishing the new and necessary collaborative research and monitoring frameworks that integrate from a small scale, what's happening at the turbine level, to the wind farm scale, to a regional scale, all the way up to the LME large marine ecosystem scale, creating a coherent science structure that can detect the types of changes that we anticipate seeing and can help us adaptively manage so that we can achieve coexistence. Next slide, please. So I've laid out some substantial challenges before us, you know, setting up the science enterprise that we need, understanding the effects and impacts, but what are the opportunities? And they are important opportunities. The one key opportunity right now is that we're all willing to work together, and that is very key. We have agreed to a paradigm of coexistence, and there are a number of developments in the Northeast large marine ecosystem that are very positive. One is organizing the various members and types of fisheries across our region beyond. The Responsible Offshore Development Alliance is formed to help better engage the fishing community and work collaboratively with our Bureau of Ocean Energy Management and NIMS on the science, on the processes for wind development, and so we can tap that really important knowledge base of our commercial and recreational fisheries. The Responsible Offshore Science Alliance, you'll hear a lot more from Lindy, is also a key opportunity, a new collaboration that's going to help fill that gap of creating a coherent regional science structure that is also very positive, because it is actually an organization that was started by the wind energy developers in the fishing industry. Actually, government was totally out of it, and they're inviting us in to help, which is excellent because we need them. And then international collaborations are really important. Learning the 20 years of lessons learned from our European partners are key, because they've been at it the longest for offshore wind development. Next slide, please. The last opportunity I see working at the LME level is innovation and new technologies. There's so many different ways that we can address the challenges that I laid out, whether it's new sampling technologies like eDNA sampling, or using visual imagery or acoustic data, or unmanned systems, or passive acoustic monitoring, so we can listen to the ocean and actually hear the animals, what they're doing, where they are, and understanding the habitat using these advanced technologies. And offshore wind, like I said before, is also going to give us thousands of new places to sample from as new platforms. So taking advantage of this innovation and technology is going to be key. If we try to address these problems the way we addressed them 10 years ago, we're definitely going to be limiting ourselves. If we address them with ways that we haven't thought about, and we can apply that to the problem and be more successful. Thank you very much.
Thank you, Andy. That was great. I'm just going to move on to Jeff because of time. I don't know how you sleep at night. I'm just going to say that. Lots of issues going on. So Jeff?
Yes.
Let's hear from you.
Great. Good morning, everyone. Thank you for the opportunity to speak to you today. I'm particularly honored, since I'm probably, of the 99 participants here, the only non-scientist. So forgive me, I feel very under-credentialed this morning. But I am here to share with you a bit about the offshore wind industry, because it is very likely the largest of the new human impacts to this ecosystem that we're seeing today. And this is something that is going to play out, as Andy mentioned, very soon, but for decades to come. And the impacts, both positive and potentially negative, of the industry are pretty wide-ranging to given its scale. But I think, as I'll mention, I think at the end of the day, its importance is quite vital, not just to the region and the global economy, but to our collective fight against climate change. By way of background, I was the former CEO of a company called Deepwater Wind that built the wind farm that you're seeing on the screen right now. That's the Block Island Wind Farm. It's the first offshore wind farm constructed in the United States. went into commercial operation in 2016. And over the course of about a decade, deepwater wind really spent a great deal of time helping to lay the foundations for the offshore wind industry in the United States that I'll speak about in a minute has now really begun to take off at a very large scale. So if you could flip the slide, please. A little close-up picture of the final bit of construction of the Block Island wind farm that was occurring in 2016. The wind farm is located in the special area management plan that Jen Mccann mentioned a little earlier. And that was quite an important bit of fortune for us, that the state of Rhode Island had created this planning process that answered a fundamental question for a developer like us, which is where is it that the state of Rhode Island would like to see offshore renewable energy built? And when you're coming to that sort of question, and you have a state that hasn't even begun to ask the question, it makes the development challenge quite insurmountable. And because of the state of Rhode Island's thinking about the long-term impacts, not just of renewable energy, but lots of ocean uses, they had started this planning process, which began to answer those critical questions, the zoning of the ocean in Rhode Island. And that process that the state went about really helped to give us confidence that we could figure out the best location and methods of building a wind farm in Rhode Island, and understand that stakeholders in Rhode Island would participate in that planning process. And at the end of the day, the process would have the imprimatur of local government. Now, something that's important about the Block Island wind farm that's, I think, quite different from what we're going to see happen next, in addition to the scale that the Block Island project, while a significant project, is only 5 turbines, and we're now talking about thousands of turbines planned on the US East Coast. But as you note in this slide, the project was proposed in 2008 and went into commercial operation in 2016. That 8-year time frame from conception to operation for 5 turbines is something that we're going to see really be compressed. And we're going to see the pace really pick up. And I understand that for folks involved in this marine ecosystem, that presents a challenge. And Andy mentioned the challenge of this, both the scale and the pace of development that we're likely to see. Things are going to get bigger and they're going to get much faster. You could move the slide, please. And this is happening globally. This is a chart that simply over time shows you how much offshore wind has been installed globally. And it's measured on the y-axis in cumulative megawatts, which is a measure of power. But you can see that when we started the Block Island project in 2008, there were only a few hundred megawatts of offshore wind in operation at the time. So the Block Island project, while it was still small, was with the first wave of offshore wind. And as we were developing that project between 2008 and 2016, you can see the tremendous growth in the installation of offshore wind globally, with the primary movers being the United Kingdom first. That's that top color. But then you can see in the last few years, the huge growth in Germany. And now at the bottom, that orange color, we can see China beginning to make some very massive installations. And if I were to project this chart to the right, we would see this 23-ish thousand megawatt number exceed 50,000 megawatts in just a handful of years. So the United States is now joining this trend. This is not unique to the US East Coast. We're behind other parts of the world. But when this industry begins to happen, it explodes in scale very quickly. So if you can turn the slide. So why are we talking about building offshore wind in the US Northeast? And this is my sort of short version of the business case. This is why it makes sense to build offshore wind in the US Northeast. If you start on the left part of the slide, can see that there are a lot of people who live really close to this large marine ecosystem in the US Northeast. This is a coastal population center. And this coastal population center demands a lot of energy. That corridor between Boston and Washington has a very large concentration of people clustered near the coast. And that also creates a problem from an energy perspective, because it's really difficult to build big power plants in that corridor. In the middle of the country, in the Great Plains, it's quite easy to build really large wind farms, or frankly, large power plants of all kinds, large natural gas plants, for instance. But in the very densely populated US Northeast, where property values are high, where we don't have many natural resources, building new infrastructure to serve that population is really difficult to do. Luckily, in the middle picture on this slide, we do have a wind resource that is located offshore principally. That's a wind map, that middle picture. And the bluer shades that you see onshore, the blues and greens, indicate relatively weak wind. The warmer colors indicate really strong average annual wind speeds. And you can see that the further to the north you get, in particular off the southern New England coast, we have really world-class wind speeds. So luckily, we have this huge supply of energy just off the coast, very close to where the demand is. And that, coupled with the far to the right, the simple picture of the shelf, is another happy coincidence that exactly where we have both supply of power and a great need for this power, we have a location that's buildable for offshore wind. Hence, this tremendous interest and growth of offshore wind in the US Northeast. Next slide, please. And so how is that manifesting itself? Well, this is a map that shows all of the individual offshore wind farms that are either in development actively or are in some stage of planning. And really those developments stretch from the Gulf of Maine all the way down now to South Carolina. And these collectively, these projects have been enthusiastically embraced by state energy policymakers. And fundamentally, the development of offshore wind is about delivering low-cost, clean energy to those population centers. And because of the challenges of serving those coastal population centers with other forms of energy in particular, most states have very strongly embraced the development of offshore wind. And now, obviously, this presents a real challenge. Just a very quick look at that map shows a tremendous amount of activity really clustered on the coast in really big developments. And we're talking about industrial scale developments. Each one of these projects is multiple billions of dollars of capital investment, with using the world's largest vessels, using hundreds and thousands of workers, installing the largest wind turbine generators that man has ever created, and installing them on top of hundreds and hundreds of tons of steel to be fixed to the seabed. So we're talking about really complicated construction that has a long lifetime. These developments are generally planned to be in operation for 20, 25, 30 years. So it does present this challenge collectively as a community on the coast on how to go about developing in a responsible way that takes into account both our need for this clean energy resource, but the need to work within this larger ecosystem and with all the existing stakeholders for many of whom this development is happening quickly, perhaps for many folks happening too quickly, and having impacts that perhaps are long-term that they don't quite understand yet. But as as I thought about this planning around a large marine ecosystem, it really jarred with the way I think about offshore wind development, because fundamentally, as an offshore wind developer, we don't think about large marine ecosystems. We don't think about the continental shelf. We think about our development, because one of the most important rules about developing a project is all development is local. What matters to my development is what's happening really close to that development. So I think, just as a general thought to keep in mind here, that when we're talking about engaging with offshore wind industry, or let's say any commercial development industry, there will be this fundamental challenge of getting the individual developer to think more broadly, to think in this kind of ecosystem way, which may come very naturally to the scientific community, but really goes against the grain of how a developer thinks. So something to keep in mind, and I'm looking forward to continuing the discussion here. So thank you for inviting me.
Thank you, Jeff. And on top of that, you know, you're talking about scale and pace, but also the different technologies that are taking place, whether it be floating or now there's, you know, Block Island was 6 megawatt, right? And now there's my understanding is a 14 megawatt. Is that accurate?
Yeah, that's right. You're right, Jen. So the size of the turbines is getting larger and larger. And frankly, that's one of the benefits of building offshore. There is very little limit to the size of the machine that can be installed. You run into limits onshore because of infrastructure constraints. But when you're working offshore, you can get quite large. And so we are now talking about turbines. I think the largest commercially available turbine today is about 850 feet from the water to the tip of the blade. That compares to about 600 feet at the Block Island project from the water to the tip of the blade. So in the last few years, we've seen, just as a simple measure of the height, go up by nearly 50%. And that certainly is not the limit.
Wow. How big do you think they're going to get, the wind turbines?
Well, I think they're going, the 14 megawatt turbine, my guess is most manufacturers are aiming for 20 megawatt turbines. I think that's generally what their R&D programs are looking towards right now. And what size that is, I don't quite know, but every time someone has predicted the maximum size of turbines onshore or offshore, they've been proven wrong within 6 months. So no one should make any predictions around that.
Thank you. Okay, Lindy.
Hello.
Hello, you're on. We can hear you.
Thanks, Jen. And thanks to Jen and JP for the invitation to be part of this panel. It's really great to see this group together and see all the folks from really all over the world participating in this webinar. And so I'm going to take a moment to tell you a little bit about our organization, the Responsible Offshore Science Alliance, or ROSA. And so Andy gave us a nice little plug in his presentation, but I wanted to give you a little bit of background of kind of who we are and what we do and how we're kind of tackling this this idea of kind of scale and regional coordination related to offshore wind, and we particularly focus on the impacts to fisheries. Next slide, please. So I am the executive director of ROSA. I'm actually our first executive director. We're a really new organization. So we're a nonprofit that's dedicated to collaboration on offshore wind development and fisheries, and really aimed at focusing on regional research, communication, improvement of data sharing, those type of things. Next slide, please. So as offshore wind really started to take off, particularly on the East Coast of the US, there was this recognized need that things were being addressed either at the state level, at the project level, as Jeff mentioned, and at kind of local scales. But there was a need for coordinated regional science, because a lot of the times, maybe it was a state agency or something like that, adjacent states were asking similar questions about offshore wind. And within the existing kind of groups and organizations and agencies, there's really limited capacity to tackle this at the regional scale. In many cases, an agency may have 1 or 2 staff that focus on offshore wind, and particularly offshore wind and fisheries. And so there wasn't quite the ability existing to tackle this kind of regional question and create a forum to improve kind of cooperative partnerships and look at what everyone else was doing, how these things could be brought together and be more coordinated. And because offshore wind is so new in the US, as several people have mentioned, Block Island Wind Farm, that 5-turbine project was the first in the US. As of a few weeks ago, there's, I think it's 2 turbines down in Virginia that are now in the water, but there's really no big utility scale offshore wind in the US. So there's this need to increase kind of the data that we have and our knowledge on the effects of offshore wind development on fisheries and really ocean ecosystems in general. So in 2019, ROSA was formed as a 501c3 nonprofit as a partnership between the Responsible Offshore Development Alliance, which Andy mentioned, which is a member-based coalition of fishermen and offshore wind developers. So this was really unique that it was a joint industry partnership between fishermen and developers, which in many cases are 2 groups that are at opposition when it comes to offshore wind. But they agreed to come together because of this need for kind of regional coordinated science. Next slide, please. So the goals of ROSA are to identify our regional research and monitoring needs. As I said, it's a new industry. And so in some cases, it's just kind of looking at what's out there in terms of research, where the data gaps are, where we should focus our efforts on offshore wind and fisheries, to coordinate existing research and monitoring. So looking at what the universities are doing and other research organizations, looking at what groups like Andy at the Science Center, what they're doing, across the board, different research and monitoring programs and how they can be better coordinated. And then really use that to advance our understanding with this key framework of kind of collaboration, partnerships, and cooperative research. Our goals are also to improve the access to scientific data. In many cases, unless you're kind of the researcher that's working on this, or even if you are, sometimes it's difficult to know what either other folks are doing or how to access data or what other data streams might be out there that can inform your project. So to improve the access to scientific data, and then to also share the research and communicate the findings, and hopefully at some point also be an organization that's administering research and releasing RFPs and doing that as partnerships through other organizations as well. Next slide, please. So when we think about offshore wind, I mean, offshore wind is really occurring on the East Coast at the LME scale, the large marine ecosystem scale. And so Jeff had a really nice detailed map of the different sites, and it was a broader scale. So Jeff's map went all the way from Gulf of Maine all the way to South Carolina. This is clipped a bit from kind of Cape Cod to Virginia. But this is just some of the sites that are occurring at in offshore wind in the US. And actually a little plug to Nick, I clipped this off of the data portal, the Northeast Ocean data portal. So thanks for that. So the sites that are kind of gridded are ones that are current lease sites for offshore wind developers that are in the kind of permitting process for development. So those are the main sites off of Rhode Island, Massachusetts, all the way down to Kitty Hawk off of North Carolina. And then the green sites are potential new lease areas that the Bureau of Ocean Energy Management, or BOEM, is looking at in the Mid-Atlantic Bight. So those could be lease sites in the future. And so, there is this idea of scale. Jeff mentioned it, Andy mentioned it, others, that, certain things you have to think about on the kind of local or project scale. Certain things are kind of on a regional or sub-regional scale, particularly if you look at something like that block of sites off of Rhode Island, Massachusetts. But as a whole, when we think about offshore wind development, it's really at the large marine ecosystem scale. It is, a large portion of the shelf here in the Northeast that is likely going to see these large-scale utility scale projects. And so we need to think about kind of regional questions to ask, regional coordination, and how this will impact our ecosystem. Next slide, please. So the way that ROSA has been formed to tackle this is kind of our organizational structure. And so the organization was formed in 2019. Ed came on board as the executive director in February of this year. So we're very new and really just starting to get up and running as quick as possible. And so I have a board of directors, which is that joint industry partnership that I mentioned. It's equally comprised of offshore wind developers. There's 5 offshore wind developers that are on the board, and 5 fishing industry members that are also members of Rhode. And so they do the kind of fiduciary policy oversight, your typical board of directors. We're working on now building our advisory council that will really have that kind of overall strategic guidance and goal setting. So we're looking to that wheel on the right there. It'll be comprised of both commercial and recreational fishermen, offshore wind developers, federal agencies, both Noaa and BOEM, the fisheries councils that we have in the U.S., so the Mid-Atlantic Fisheries Council and the New England Fisheries Council, as well as Atlantic States Marine Fisheries Commission. They'll be part of that. And then the regional states from Maine to North Carolina. So those will be the groups that come together. It'll probably be around 40 people that help drive the strategic guidance, kind of the goal setting, what the focus should be, what the needs are in the region. And then we'll also have a research advisory board. So this is where we'll bring in scientists, academics, and others to really help with scientific review, advise on scientific issues, those type of things. And so through this organizational structure, through our board, through our advisory council, through the research advisory board, we're really looking to bring together experts in the region to advance research and monitoring, focusing on fisheries and offshore wind, with this really, underlying effort to key in on collaboration and cooperation. So taking the existing efforts, taking the work, all the great work that folks are doing, and pulling this together to think regionally about offshore wind and fisheries. And so as we kind of build out, we're looking at our strategic partnerships, groups that we can work with. It's really great to see the work that Tatiana and others are doing kind of in the long-term monitoring. Those type of things are the type of research that ROSA and this effort will bring together to think about how we can look at efforts of offshore wind. Because it is so new, there's a lot of unanswered questions, and it's going to be a few years of kind of trying to look at the pace of development and learn as much as we can, as quick as we can. Thank you. Jen, you may be muted. I don't hear you.
Can you hear me now?
Yep.
Okay. Thank you very much for that presentation. And we all know that this supplemental EIS just came out, and I'm wondering, again, I know it just came out, so you probably haven't read it page for page, but knowing that they're looking at the cumulative effects of wind, can you talk a little bit about that?
Yeah, I think that's a challenge, right? So a lot of what's built into the regulatory process with U.S. offshore wind is that kind of a project scale, as Jeff mentioned, and it's a combination of the kind of federal regulations as well as the state regulations through either coastal zone consistency assessments or thinking about kind of cable landings and onshore infrastructure and things like that. Vineyard Wind, I think when they started was, that graph that Jeff showed of how kind of quickly there was this uptake in offshore wind. The same thing kind of happened in the US. I think as a few years ago, there may have been, a handful of lease sites, but the projects weren't as far in the permitting process. And so there were several projects in the US that really ramped up their development and their permitting. And then there was a recognition that we had to think more beyond kind of a single project, but look at kind of cumulatively across projects. And some of that was really driven by concerns with the fishing industry. There's major concerns from fishermen that these projects will impede their access to, longstanding fishing grounds and things like that. So it's either, access through changes in their ability to transit across an area. And that map that Nick showed about kind of vessel transit, that some of that was driven by some of these questions that are happening both in New England and the Mid-Atlantic about how the fishermen may be fishing their grounds maybe further offshore, but they need to get through these offshore wind sites to get to their fishing grounds, as well as vessels that may be fishing in those areas, you know, particularly for mobile gear fisheries, trawls and dredges and things like that, that may not be able to tow their gear through them anymore. And so it might not have been as much of an issue if you're looking at, say, one project, but then when it was 2, 3, 5, 10 projects, and fishermen are traveling, you know, from the Cape down to New Jersey and vice versa to either fish or land their catch, there's a recognition that we had to think about this more kind of cumulatively. And I think that's, you know, one of the things that caused the Vineyard project to go into the supplemental EIS to look at cumulative impacts. It's a difficult thing to look at, certainly, but I think it was a recognition that as offshore wind rapidly grows in the US, there's multiple projects that are going to be impacting the ecosystem, the species, the environments, and then as well as things like the socioeconomics of our fisheries.
Thank you. And we're encouraging you all to put in your Q&A questions, and we have JP and others taking a look at those Q&A questions. And also, if you want to ask your specific question verbally, either raise your hand or write it in the chat box and or the Q&A, and JP will identify that as well. Jeff, you mentioned you know, that obviously most development is small scale, or it's focused. And so here we have, you know, we didn't have ROSA a while back, and also now with this supplemental EIS, which is encouraging or requiring more cumulative. Do you feel that, what is your thoughts on that? Do you feel like this is where these efforts, cumulative efforts, are bucking the tide, and it's not going to work, or what kind of advice would you give to Lindy as far as making sure it does work, and to encourage developers to look regionally?
Yeah, well, I think, Jen, that what we're seeing in the supplemental EIS is the regulatory body, the principal regulatory body in the US, catching up to what's actually happening in the commercial world. I think the pace of development and the scale of development over the last few years has exceeded, I think, anyone's expectation, including the expectations of the industry. So it's not surprising to me that the regulatory world decided to hit a pause button to say, let's take another look at this, because our expectations have really been exceeded. We didn't see this coming. And so I think it's a good thing what BOEM did to take another look at the overall pace and scale of development, and how one individual project would contribute to that cumulative impact. And I think it's in an inevitable consequence of the industry's success. And what's interesting for me is that these impacts, or these larger sort of impacts of the scale of the industry's growth, are not just limited to sort of the impacts that we may have to, let's say, commercial fishing, but we've got complicated issues to deal with in the industry when it comes to, let's say, using port facilities. It was easy to figure out which ports you were going to use if there's only one project in the region. But now if you have 2, 3, 4, 10 projects all trying to be built within the same 3 or 4 year time frame, now you're fighting over port facilities. Now you're fighting over locations to land your offshore cable. Now you're fighting over perhaps the workforce. So the impact, the consequence of this growth go beyond the impacts on stakeholders. It really does impact the industry itself. So I think that that dynamic is a recent realization that the industry is taking on, that the pace of our growth is creating complexity that would not otherwise be there for individual projects. And I think because of that, you're seeing the industry begin to recognize the value for these collective efforts, and hence the ROSA effort, hence the engagement with the Rhode effort. And I think those are natural outgrowths of the complexity, but it's not, I think, maybe perhaps luckily for the idea of coordination, there are actual sort of commercial complexities that drive the industry to think more deeply about the bigger picture.
Any advice to Lindy?
I hope Lindy's a good politician. She must be. She must be to be able to hold it together.
We're a good mediator, at least.
This next question, Nick, I wanted to direct to you, and then maybe Tatiana, is you all have been hearing about this, accelerated growth of offshore wind, significant amount of collection of data. Nick, I know in the supplemental EIS they've been using your data. So Nick, in particular, are you able to, how are you integrating this new data collection information that the wind developers are getting? How are you incorporating that into your data portals?
Well, I would love to have that discussion with the developers, and I think we're all just starting to actually have that discussion. I think you can, one of the, I know that one of the big questions that we've always dealt with is that we're collecting information before offshore wind development. We were already collecting more information than is being published or being used. And in the last several years, not just our portals, but there's this proliferation of portals that are out there to bring all of this data collection out and publish it for use. But we're now talking about data collection in very particular areas at a scale that maybe we haven't seen before. And we're talking about an amount of data that we maybe haven't even seen before. And so I think we're just starting to get a handle around what all of that data collection looks like. So I think it's an ongoing discussion. I think it's actually just starting. I think you can actually, a good example of it is if you actually dug in to that, if you zoomed in on those AIS data sets that I was showing earlier, and you zoomed into the various wind energy areas, you would see the amount of survey vessels that have been tracking back and forth in those areas over the last several years. And that would give you a good sense of just how much data collection is happening in any one of those areas. And we're talking about terabytes and terabytes of data. We're talking about proprietary data in some cases, or in a lot of cases. And I think there's an opportunity to really improve our habitat mapping and improve our understanding of what's going on in those areas and beyond as we start to integrate it into some of these regional products that we have.
Great, thank you. And Tatiana, when you look at this growth and increase, data collection, monitoring, as a scientist, how do you see this?
More data is better. Yeah, so I see it from two sides. One, think back to those slides that were shown. Lindy showed that a zoom in of where wind farms are going in, and there's that set of farms off of Martha's Vineyard. On the one hand, the set of farms that are slated to go in are right across our focal transect that we take across the shelf 4 times a year. So, how is the installation of a wind farm actually going to impede our ability to collect data, to even go through there? Because some proposals say, here's the wind farm, you may not transect through the wind farm at all, right? So, having to shift our location. And so some of these things are issues are coming to light now with the siting of these wind farms. And that's going to be true. Andy talked about the long-term sampling that they're doing at Noaa. You know, they have a lot of sites that go right through those proposed wind farm locations. So that's the one hand. The other hand is, you know, we're getting a lot more data, and that's really exciting. Some days I feel like I'm trying to drink through a fire hose, right? We have something we haven't talked about here is the IOO, the International Ocean Observatory Pioneer Array, which is at the shelf break. So it's at the edge, the southern edge. If you go from Martha's Vineyard straight south, it's at the shelf break. And that's collecting real-time data, right? So any of us can go to their data portal and get real-time data of what's happening right at the very edge of the shelf. We also have a lot of autonomous vehicles in the water associated with that array. And so Nick's job of gathering that data is really important. One thing I do want to point out is that we have, you know, we're getting a lot of data, but having the people in place who can evaluate that data, who can understand whether that data has been quality controlled or not, because you could have data, but if the data is poor or the instrument is off, you know, it's not going to help you in trying to answer your question. So really having people in place who have the training to analyze that data in its many facets, understand its provenance, because you have a lot of different users or different producers of data. They may call something temperature, but they may be using different kinds of instruments to do it, right? So even something as simple as, you know, as temperature or wind speed, really understanding what the instruments are that generate this. So I think we do need a workforce that's trained to integrate really disparate data sets. And so the work that Nick is doing in particular, I think is really valuable on this.
Right. To ensure that they're, as you're saying, using the same instruments and also using the same methods to collect the data as well.
Yeah, and in a lot of cases, we're not going to use the same methods to collect the data, and that's okay. And understanding that, you know, just making sure that the different methods or different instruments are comparable, or understanding when they were last calibrated so that, you know, each instrument drifts, right? And if you're wanting to look at some time series of a variable out there, you want to understand, you know, when the instrument was last calibrated to know whether what you're seeing is actually a drift in the instrument or something real out in the environment. So, you know, there are issues associated with it, and they're not insurmountable at all. They're things we deal with all the time. It's just a level when the general public hears, oh, we had all this data, I think there's a tendency to think, oh, it's like it's ready to be served up. But there's a significant chunk of investment required to make that data digestible.
This next question, I'm going to ask both Lindy and Jeff. This is from John Hoey, and it's about are developers receptive to coordinating their monitoring activities to economize on monitoring operations that will advance standard data formats, processing and access to data, and analytical visualizations and assessments of change over time. So, Lindy, I know you know half of your advisory board is made up of developers, and one of your priorities is monitoring. How and again, knowing that you're just initiating this conversation, how are you feeling about that coordinated monitoring? And Andy, if you have something to add on this too.
Thanks, Jen, and thanks, John. That's a good question. And I think that the developers are starting to realize that there is utility in kind of coordinating their monitoring activities for different reasons. And there's been a push from the research side to coordinate them so that, you know, that what Tatiana talked about, so that we have data that's comparable, that maybe is using similar methods. And, you know, in terms of fisheries, we're thinking about, you know, maybe projects collecting data that can be integrated in some of those long-term studies that Andy had on his chart, so that we're using methods that are comparable to those. But, you know, I think what we've recognized is that either because it's driven by regulatory requirements or whatever, that these projects are asking similar questions. And so what we're hoping through ROSA is to make sure that the monitoring plans are done to design kind of, you know, rigorous hypothesis-driven science that has the statistical power to kind of answer questions, and that they're not getting into that kind of area where you're collecting a whole lot of data that's not actually giving you any information. And so what we've done is kind of started to pull folks together, you know, developer staff that are designing their monitoring plans and things like that, to talk about how we can coordinate this regionally. So for example, Andy and I are working together on an interim working group that's looking at regional coordination for monitoring of offshore wind related to fisheries. And so, you know, ROSA's long-term goal is to have some kind of regional guidance, maybe standards of practice, you know, kind of science criteria, you know, for peer review and things like that. But there's this recognition that that could take 6 months to a year till we have kind of our full build out. In the meantime, you know, Vineyard and Ørsted's projects and Equinor and others, they're full steam ahead in terms of moving their projects forward. And they're about to start a lot of their monitoring plans, particularly like when it comes to pre-construction monitoring for impacts and getting some of that baseline data. So we've brought together a group of folks that includes federal agency people, a few state agency people, scientists at different universities or other research organizations, as well as a few fishermen that work in kind of cooperative research to talk about how we can coordinate this better. And I think, you know, the goal is that we're thinking about the science questions, we're collecting good data, we're building these partnerships, and overall, you know, we're streamlining the process. So if you're a developer, you know that you have this group that came together and said, here's what we want to see, and you can adhere to that. And if you're a scientist or a fisherman or a regulator, you have that chance to say, a good monitoring plan should look at this type of information, should ask these type of questions, should collect this type of data, and should be able to integrate with these existing studies as well. And so we're trying to pull that together as quick as we can. And I think I've seen at least a willingness from the developers to come together, and, you know, maybe their reasons for doing it could vary. But in the end, I think, you know, the goal is to collaborate on a process that's as universal as it can be, looking at the scales that we might be looking at.
Thank you. Jeff, do you have any observations on that?
Sure. Yeah, I think in general, you'd probably find most developers, as Lindy mentioned, be supportive of the concept of this coordinated monitoring program. I think that I think we're very likely to get there, but you have a few things that are happening in the interim. First of all, you have a fairly immature industry in the U.S. where most of the developers and companies are just catching up to the tremendous growth that we're seeing. They're all on different timelines. They're all focused on their individual projects. They're all focused on the most immediate things that have to happen. So we're not quite at the point as an industry in the US where coordinated, collective efforts for long-term programs are at the highest level of priority inside of organizations. So I think that, that hard work that Lindy's doing now to try to build the trust between the various developers and programs on these issues is important, and I think it'll bear fruit over time. I wouldn't expect it to happen overnight. And remember that all of these entities are highly competitive and are looking for every edge they can get on the person sitting next to them at the table. So keep those factors in mind. Collaboration does not come, again, easily to these groups, and it's a relatively young industry in the U.S., so it'll take a little bit of time to develop that muscle, collaborative muscle.
Great. Andy, I had another question for you, if that's okay.
Yeah.
So we have a question from Vladimir Radchenko. He's asking a question. Can we expect that offshore wind industry facilities will be supplemented with the large-scale aquaculture farms in the future? And I'm asking you that question because I know you traveled to Europe and you've been engaging with ICES, the International Council for the Exploration of the Seas, and looking at multi-use strategies and whatnot. So wanted to, I'm not sure if this is, just wanted to get your perspective on that.
Sure. The question, if I repeat it, is co-location of offshore aquaculture with offshore wind.
Yes.
Yes. In the U.S., we're a little less similar to the offshore wind industry. We are behind other parts of the world in terms of developing industrial scale aquaculture in our federal waters. And part of that is just the nature of where we are in the process of creating the regulatory framework for doing that. Now, the president just signed a seafood executive order to advance sustainable seafood production, both domestic seafood production, both wild capture and aquaculture. And for years we've been talking about advancing offshore aquaculture. But none currently at industrial scale exists in the U.S. So we are a few years behind, but eventually we will catch up. So much of the same issues that we're facing with developing offshore wind for renewable energy, we will have for developing offshore aquaculture for renewable food production. You know, conflicts with existing ocean users, science impacts, understanding the effects, etc. In Europe, there is groups in Europe that are looking at this, looking at co-location. I believe Belgium now has a co-location, a new policy, so they'll be exploring, production of aquaculture with offshore wind. I think that, I'm not going to speak from the developer standpoint, like from Jeff, but I know it is complicated to advance an offshore wind farm. It will be more complicated to advance an offshore wind farm and an aquaculture facility, but there could be very good advantages because of the science information you would need to permit and regulate both. It could create major efficiencies. It's definitely something that we need to take a look at that makes sense. On face value, it makes sense, but when you dig into the individual projects, similar to sort of the insights that Jeff provided, there may be some barriers to making that happen, but we should try to overcome those barriers.
Hey Jen, if you don't mind, let me just jump in here on this one, just as a quick thought. My knee-jerk reaction here, and since I don't actually work for a developer right now, I can speak very broadly. Let's say from a developer's perspective, I would be willing to bet quite a bit of money that if you were to ask the CEOs of these development companies, in all honesty, not on the record, what they thought of this idea, they would be uniformly opposed to it. And they're uniformly opposed to it because of the enormous legal, regulatory, and operational complexities of co-locating two really complicated businesses right on top of each other. It's really, really hard to do. And so I think the industry would need to see a lot of work on a lot of pilot programs over a long period of time and convince lots of lawyers, lots of banks, and lots of regulators that it could work. So, in all honesty, it's going to take a long time to get to that.
Okay, I thank you, Jeff, for that reality check. And but why they're doing it in Europe?
Well, I would say, so most aquaculture growers are pretty small operations. And so you've got a really small operation dealing with a multinational publicly traded company. And so the lawyers will come along and say, who's going to assume liability for what happens near that foundation? okay, the aquaculture company isn't worth much. So even if they assume the liability, how are they going to pay us if they damage something? Who bears responsibility for monitoring what happens out there? Are we going to be responsible somehow? What if there's a conflict and we need to get to our turbine under really bad weather conditions? Can we just roll over their aquaculture facilities because we need to get to the turbine? There is a very, very, very low risk tolerance towards among lawyers, financing companies, and developers when it comes to things that aren't fundamental to the business of what you're doing and doing offshore wind. So I'm not saying it can't be done someday. I'm saying that I think we're pretty far because, to my knowledge, we've never seen a real set of long-term pilots at any kind of scale co-locating aquaculture and offshore wind. And so I think we would need to see that played out over some period of time before people in the industry got to a level of comfort.
Thank you, Jeff, for that clarification. I'm going to pass it over to JP. He has a couple of questions from the Q&A as well.
Hi, everybody. I wanted to start with one question. I wanted to take us off offshore wind for a second. We've heard a good amount about that. Obviously, on many people's mind is COVID-19, and it's raised some issues about our coast and how we use it. Thinking about our coastal communities and blue economy, how prepared are we to understand and respond to short-term changes or impacts like COVID or major hurricanes? I think that's one of the concerns that we have. Obviously, we're talking about long-term, and there's always climate change is another big concern. But how about on the short term? Maybe Andy or even Jen, if you want to chime in on communities and responding.
Thanks, JP. Working for the federal government, response time is often difficult, but I will say that in our fishery science and management capabilities, we are often forced and and often achieve very rapid go out, collect data, take that data and make decisions on it. You know, for instance, we do scallop surveys on an annual basis. In that management advice, that data is it's terabytes of data through different types of imagery data that we collect through our Habitat Cam, and then various surveys that happen across the shelf. That data is crunched, assessments are developed, and we give management advice, at the every year for the dynamic area management for actually one of the U.S. most valuable fisheries, close to $500 million a year. So there are examples where our systems are set up to do rapid scientific inquiry and take that scientific understanding and move it into the management arena. Where we are with the pandemic, with COVID, is very different. The industry the fishing industries are shocked by this, but they're also, and some of them are moving very rapidly to adjust and adapt. With stimulus funds that come through to assist fishermen through the federal government, it takes time for those funds to get out and make sure they're adequately and effectively deployed. So to do this responsibly, it takes, come back to that term collaboration. There's things that private industry and the private sector can do to work with their supply chains and work within their regulatory frameworks to do. There's things that we can do as the federal government to facilitate that, whether it's scientific efforts. Our science operations have been shuttered due to COVID. Those things are slowly getting back up, but it's slow. So I don't know if I have a good answer, but there are things that we do very well on a rapid scale, and we need to sort of think through and apply those success stories to this new world that we live in.
Thanks, Andy. Yeah, Jen, did you want to?
Yeah, sure. I'm sorry, I'm having a dog issue right now. We just finished a report on Rhode Island's blue economy. Started in March, it ended in March, and so we have a nice baseline as far as what has been Rhode Island's blue economy, and I would say. Obviously, tourism and recreation has taken a big hit. And then also the aquaculture industry, the majority of Rhode Island's aquaculture industry, and I would say it's similar within the Northeast, is the market is primarily restaurants for our oysters. And obviously with COVID, all of that is marketing. That market has gone away, and so we have been working with, and others have as well, to pivot the aquaculture industry to more of an online marketing opportunities, to create new markets, to encourage local communities to purchase oysters and learn how to shuck them or grill them on the grill. And so I think the aquaculture industry is hurting significantly because of that change in market. But we do see, we've been looking at, for example, the recession, where the marine trades industry was significantly hit. And in Rhode Island in particular, because we are a strong network of individuals, we sort of have 3 degrees of separation from each other. We have examples of how industries within the blue economy have been able to pivot and also to be able to adapt to and diversify their products and their services, so that we've been able to recover quite well, especially compared to other states and regions. So the expectation is that we will bring our resources together around these blue economy sectors, and they will definitely look different, but in the end, maybe they'll be a little bit more resilient.
Thanks. Maybe actually quickly ask that to Tatiana and Lindy. Maybe scientifically, how well are we able to identify? We heard the federal government maybe not always easily able to respond, but I know we have instruments. Can you maybe speak to that? Can we detect changes from storms and COVID, for example?
Yeah, sure, I can speak to that. I think there's two different answers there. One is, how can we respond to short-term events like hurricanes, oil spills, any kind of event that happens out there? And the National Science Foundation has a sort of a fast-track funding opportunity for those kinds of events. For example, with the Gulf Horizon oil spill, a number of really great researchers were able to put together research cruises on very short notice with funding from the National Science Foundation to get out there and sample quite immediately after the event. And this can happen in the case of other events as well. So there is a mechanism for us to get funding, because of course anytime you go out to sea, it's quite expensive. There is a mechanism for that, and so that's really good. And then at the state level, there are some rapid response groups, I will say. And in terms of how easy it is to get funding at the state level, I think, it's in Rhode Island anyway, it's a small state, and if something really needs to be done to get out and sample that affects the blue economy, I think, it's possible to lobby for that. And then, then there's the other answer, which is how something like COVID, which is happening on land, affecting, our activities out at sea. And I can tell you, we've had two, so far in my lab, have had 2 major oceanographic research expeditions canceled because of it. because of the danger of sending people out on a ship in this time. We're currently, the NES LTR, this Northeast Shelf Long-Term Ecological Research Project, we are currently coming up for our summer cruise at the end of July. And we are in conversation with the ship operator and amongst ourselves. And we've come up with a protocol for self-isolation of all the crew and scientists that are going to be on board. And this has happened with another LTR cruise that recently went out in the Gulf of Alaska. But basically some heroic efforts of scientists and crew to basically self-isolate for 2 weeks, undergo multiple rounds of testing, and then get on the ship. And basically we'll have reduced crew, so the people who do go out are going to work twice as hard as they might otherwise just to get the samples done. And then of course, the challenge when you come back from sea is that you need another round of tests, because you don't want to have been infected on the ship and then bring that back to your friends and family. So there are ways that we're figuring out how to still get out there. I want to point to Andy here, because he can talk about the Ecomon cruise, for example, that was canceled, that we were scheduled to join as well. So maybe I should say three research expeditions, at least in my lab, have been canceled. So.
Yeah, the only thing, thank you, Tatiana. The only thing I was going to add that, having environmental intelligence systems that are resilient to these types of perturbations is critical. One example where we do have that is many of our fishing industry vessels, particularly in the Northeast is a leader in this, are wired up and part of our research study fleets. So every time they're out there making a tow, we have temperature and depth probes actually on the gear itself. We know when it goes down in the water column, we know what depth it's fishing at. We're collecting temperature, depth, salinity information. Some of these boats even have weather stations that are communicating weather data to the National Weather Service. And so having that type of collaboration and working with the private sector on, and deploying our environmental intelligence through them can make us even more resilient when we do have issues. So when our white ships are mothballed and the fishing industry is still fishing because they need to bring food into people that are hungry and want to eat seafood, many of them are capturing really important environmental data and data, and biological data on their catch. Doing that at scale is probably something that we need to think about.
If I can jump in one more time here. Andy had a good point about the autonomous, we'll call them autonomous samplers, right? Or data collectors, where you put something on the nets and on the ships. We also have the Martha's Vineyard Coastal Observatory, which is an autonomous observatory off the coast of Martha's Vineyard on the southern coast. It's a cabled observatory, and it's collecting data 24/7, whether we're out there or not. So that's an example of another kind of autonomous setup. And it's able to collect biological data as well as physical data, which is really important for understanding how that base of the food web is responding to the environment. So we do have some autonomous capability, but what we can't do with what's in the water 24/7 is some of the experiments that led us to test alternate hypotheses for different mechanisms.
Thanks, Tatiana. Yeah, I'm glad you mentioned that. I was going to bring that up on ocean observing. This is where it's always out there, and that's a real advantage of it. I think what this conversation really highlights is how we need to be resilient, not only in communities to be prepared and how do we keep markets open and so on, but also as scientists to keep some data so we can understand these dynamics. I wanted to sorry.
I want to jump in on that real quick.
Oh, yeah, of course, Nick.
And I'm gonna take it from a different perspective, a slightly different perspective, and that's not the response, and going back to the map that I was showed of vessel traffic, that's essentially a map of economic activity in 2019 in relatively good time, economic time. In 2020, I suspect that map will look pretty different under a recession, and we've been doing this now for long enough that when we were looking at AIS data in 2009, 2010 with the shipping companies, they said, don't take that as the picture of what might be the future because we're just emerging from a recession. So I think when we're looking at some of these information sources going forward and thinking about management, we're going to see, we need to take into context those changes, whether they're economic or environmental. And in this case with COVID, what's likely to, if you're just looking at a map of 2020, you're likely to look at what is a lot less economic activity and may not be representative of the activity that you need to consider when you're managing offshore.
Thanks, Nick. I wanted I think we have time for one more brief question, which I was hoping to direct to Lindy, and to tie in two questions from the audience. One related to plastic. The question was brought up about paint being an important source of plastic for offshore wind. But of course, we've heard a lot about marine plastics in general. And so what do we know about plastics? And then secondly, tied to that, a question was about citizen science. And I was curious, maybe, Lindy, if you could address the science of pollution and how to engage citizens, how that might feed into ROSA's efforts.
Thanks, JP. Yeah, I mean, those are both good questions. And quite honestly, they're both things that we haven't discussed as much as the others. I think the challenge that we have as ROSA is because offshore wind is so new, because there's so many unknowns in terms of kind of impacts. Excuse me, some of the questions that we're thinking about are really fundamental, kind of habitat impacts, vessel access impacts, those type of things. But I think there is the ability to ask some of these other questions as well. And so, in terms of plastics and things like the issues with paint, it's not something that commonly comes across my desk, but maybe it's something that should. And maybe, particularly if we're looking at ecosystem level impacts and trophic impacts and things like that, it might be something that we need to consider more. And that question of citizen science is a really great one. And I know, I should mention, so ROSA focuses on offshore wind and fisheries. There's some parallel efforts that are going on focusing on wildlife. So, marine mammals, sea turtles, birds and bats, those type of things. And we deliberately separated the fisheries from the wildlife, even though there is some clear overlap between them, particularly when we talk about habitat, when we talk about forage fish, things like that. And the citizen science question, the first thing that came to mind is that I've heard a lot from fishermen that they see observations of bats offshore. So there's something where there's a huge data gap on, offshore use of bats. And there's these fishermen that have been saying for years that they land on our boats, we know they're out there. And so I know there's been some folks that have proposed in the past some citizen science type of efforts using fishermen or others on observations that they're seeing offshore. And I know these are commonly used in, marine mammal studies and things like that. So I think there's certainly room for that. In fisheries, one thing that we push a lot is collaborative research with fishermen. And so the fishermen are our scientists as well. So whether it's we're using fishing vessels for research, we're using, these really great experienced captains to run trawl surveys or something like that. They're through NIMS and through other programs. There's a long history of collaborative research with fishermen. And so that's something at ROSA that we certainly are keyed in on and is a priority for us as well, and involving fishermen, certainly as kind of citizens in the conversation from the very beginning. But those are really great questions about kind of microplastics and citizen science, and certainly things that we should be thinking about, and both on the kind of ROSA fishery side as well as the wildlife groups as well. So thanks.
Thank you, Lindy. We're getting close to the end, believe it or not, and we have a question we'd like to throw out to anyone who'd like to answer it, although I am going to start with Andy. So as you all know, one reason we're doing this panel and the other panels is because of the Decade of the Ocean, and to really focus, be strategic, think about, what are opportunities and challenges and whatnot. So again, we'd love to hear from all of you very quickly, less than, I'm going to say 30 seconds, because some of you are a little long-winded, including myself. But Andy, what represents the greatest concern for the future of our you know, of our oceans and coasts, especially considering we are now in the ocean decade?
The greatest concern in 30 seconds that comes to mind is rapid change. We have rapid environmental change. Our LME is experiencing the most rapid rate of temperature increase of you know, the Western Gulf of Maine of any body in the water. Our LME is experiencing some of the most rapid and large scale changes in human uses with offshore wind energy development. And so I would say the challenge is building our LME resiliency in terms of science and collaboration and innovation to meet those needs.
Great, thank you. Tatiana, do you have anything to say?
Yeah, I think, you know, I agree with Andy. I think one of the biggest concerns is the change that's happening in the ecosystem while we're trying to study it. And trying to study something that's changing as it's changing can be very difficult if you don't understand the baseline of the system. So we're feeling like we're doing a lot of catch up there. And then the other thing I want to mention as we go forward in this ocean decade is that I would really like to see more engagement across the community in ocean issues, so that we have a wider swath of people who are studying the ocean from all backgrounds, so that we're really engaging the entire community, the diversity of communities that live along the shore. And I think right now we're not doing a good job of that. I'd like to see that change.
Great, thank you. Lindy?
Yeah, I mean, I think I would echo both what Andy and what Tatiana said. And I think, you know, where I sit, the challenge is being aware of kind of all the things that are going on, which, you know, I live and breathe offshore wind, and there's still things that I can't keep up with, let alone all the other things, you know, in terms of oceanographic research and things like that. And then how do we educate, inform folks about, you know, things that are happening, efforts that are going on. You know, I think there are great groups, you know, like Jen's work and what they're doing in terms of kind of public information and things like that, things like these types of webinars, but it's hard to keep up. And so trying to figure out, you know, my whole role is about coordination, and it's really hard. And so how we all keep up with what's going on, how we stay informed, and how we make sure that that information gets out to the public, so that they're aware too about changes that are happening offshore, how important they are, and how much we need to pay attention to them. And I think, you know, those discussions of COVID kind of brought some of this to light about, you know, in fisheries, we saw how much it impacts, you know, how much we harvest and how that gets to people and things like that. And so I think just trying to figure out how we coordinate this is certainly my challenge for sure.
Thank you very much. Appreciate that. Jeff?
Yeah, I think what everyone is getting to is the need to make sure that we have enough resources to focus on this change, and that we're able to communicate to the broader community how important what's happening out there in the ocean is to all of society. It's not just about fishermen, and it's not just about conservationists, but how do we get enough attention and focus with policymakers and general public so that we have the resources to deal with the changes that we're facing. And I think that that requires a constant struggle.
Thank you. And we started with Nick, so we're going to end with Nick.
And I think by the time you get to me on a question like this, it's all been said, and I agree. So I just hope in the next decade that we all spend as much time enjoying the ocean as we do talking about it.
Love it. That's a great way. Thank you, everyone. I really appreciate you guys sitting on the panel and asking these amazing question participants. I'm going to pass it over to JP. Thank you very much.
Thanks, Jen, so much. Everybody, we've had a lot of great insights today. We've heard about how we're doing science as change happens, and we've got good tools to develop understanding over short time scales and longer ones, as well as from local coastal scales to offshore and regional scales. Tatiana and Andy spoke about that. Of course, we need data and we need to share this knowledge to address historical and new impacts like the major system-wide offshore renewable energy that we heard about from Nick and from Jeff, of course. And in the end, partnerships are going to be really critical to success. And Lindy is obviously, and Rosa, and of course, working with everyone here on trying to be successful in this regard. A big challenge, which was highlighted by Jeff, I think, is that we often think locally. And for example, developers are thinking locally, but we also need to be thinking about our large scale impacts and how do we measure that. Another point I want to make is that the Northeast Shelf system is really well studied and data rich, and that's great for us. There's most LMEs around the world are really lacking in this insight and knowledge, and so that's something where we need to help spread knowledge and hope and probably resources to make that work happening, and that's obviously something that the LME community is doing. So I want to thank everybody for attending. We will continue this conversation. Please follow the website for the other videos and for more information. Again, I want to thank the speakers and the supporting organizations. And again, thank you for coming. Be safe and be well. We'll talk to you soon.
Thank you.
Thank you. Oh, we'll do a round of applause. Why don't we try and unmute everybody? See if we can do that. Oh, Sarah's got to do that. You're a host.
Okay, let me see if I can do that.
Right click in the panel and choose.
Zoota.
All right. Well, how about the panelists? We can do a round of applause.
Good job, you guys. Thank you very much. Awesome.
Everybody, thank you for joining us.
Bye. Take
Thanks,
care.
everyone.